Assalamu alaikum wa rahmatullahi wa barakatuh. I'm teacher Ahmed Jamul. I'm glad to talk about document 4 of chapter 15, ovarian feedback control on the hypothalamo-pituitary axis. Back in the previous documents of this chapter, you have learned that the hypothalamus and the pituitary make the control center in the brain. Hypothalamus secretes the hormone GnRH that stimulates the pituitary gland to secrete the hormones FSH and LH. The effector organ of these two hormones is the ovary. In response to the pituitary hormones, the ovarian structures will secrete variable amounts of estrogen and progesterone. But if this mechanism is continuous in the same manner, then how come the amounts of pituitary hormones vary throughout the female cycle? Why do they reach a peak just before ovulation but decrease afterwards? In this document, you will find out what controls the hypothalamo-pituitary axis and how are the female hormones affected by the environmental factors. Some experimental studies will help you find out what controls the hypothalamo-pituitary axis. In a female mouse, the bilateral ovariectomy, which means the removal of both ovaries, leads to the fall in the blood level of estrogen. This is totally expected, right? Now, you might be saying, yes, this decrease happens since estrogen is secreted by ovarian structures, and in the absence of the ovary, estrogen won't be secreted anymore. But after this ovariectomy, an increase in the levels of FSH and LH is observed. I know that this is not an expected result for you. In another experiment performed on female sheep, when the female is injected with estrogen, the release of GnRH stops and that of LH decreases. What conclusion can you make from the previous two experiments? It must be obvious that the variations in the ovarian hormones affect the function of the hypothalamo-pituitary axis. But can we say that the ovary controls the hypothalamus and pituitary? If we go back to this functional diagram, remember that the control center in this system of regulation is the hypothalamo-pituitary axis, and the effector organ controlled by this center is the ovary. So we cannot say that the ovaries control the hypothalamo-pituitary axis, but instead, we can say that the ovarian activity exerts a feedback control on the hypothalamus and pituitary. But what does the term feedback control mean? To answer this question, let's refer to document D of your books that shows the regulatory system of the ovarian hormones. This document shows how the level of ovarian hormones is regulated in the female body, stimulated by the hypothalamus. The pituitary releases LH and FSH. The effector organ of these hormones is the ovary. The ovary responds by secreting a certain quantity of estrogen and progesterone. Thus, the level of ovarian hormones in blood changes. The hypothalamus and pituitary detect this change in the level of ovarian hormones. The control system responds by changing in turn the amounts of FSH and LH, and the cycle continues. The effect of the ovarian hormones on the pituitary and hypothalamus is known as the feedback control. Now, the feedback control exerted by the controlled variable on the control system has two types: negative feedback control and positive feedback control. To explain what is a negative feedback control, let's take the example of the thermostat and the furnace. The thermostat has a sensor that detects the ambient temperature of the house and controls the furnace. On the other hand, the furnace is the heater that heats up the entire house. In this example, The thermostat is the detector of the control parameter, which is the room temperature, and at the same time, it is the controlled center that controls the activity of the furnace. The furnace is thus the effector that it changes its activity in response to the thermostat by increasing or decreasing the heat released. The following video explains how does it work. Let's say that you set the thermostat located on one of your walls, and in a utility room there is a furnace connected to heating ducts that distribute heat to the rooms, and there is a wire that connects the thermostat to the furnace, where we often set the thermostat for the desired temperature 25 degrees Celsius or 77 Fahrenheit. But lately it might be cold with a lower temperature, let's say 23 degrees Celsius or 74 Fahrenheit. The thermostat sends a signal to the furnace which will respond by pumping heat energy to warm up the room. The temperature of the room starts increasing to reach the desired temperature. This increase in temperature is detected by the thermostat that in turn sends a signal to the furnace to decrease its activity or turns off. In this case, we say that the increase in room temperature causes a decrease in the activity of the furnace. This is a negative feedback control. Now, to explain the other type of feedback control, which is the positive feedback control, let's take another example. A smoke detector connected to an alarm where the detector detects smoke from fire and stimulates the release of the alarm. The following video clarifies the notion of feedback through this example. Let's say that a smoke detector detects smoke in the room in case of a fire. You have a smoke detector in every room in your house. Let's say a fire begins in the living room, but the smoke detector nearest to the fire will activate first and send an alert noise. But as the smoke becomes thicker, the smoke detector causes the release of more alarms in a more intense way. In this case, positive feedback encourages the alerts, so one by one, all the other smoke detectors will turn on and send loud noise. In this case, we say that the increase in smoke encourages an increase in response of the smoke detectors and thus the alarm. This is a positive feedback control. The experiment performed in document A of your books will show the different types of feedback control exerted by the ovarian hormones on the pituitary. By the end of this experiment, you will find out when is this feedback control negative and when it is positive. In this experiment, a female monkey that has been ovariectomized earlier receives two different injections of estradiol or estrogen. Starting from T0, it receives constant and continuous injection of small dose of estradiol, while it receives a single overdose of estradiol at time T1. The first curve of document A shows how does the level of estradiol vary throughout the experiment. We can easily distinguish three different variations in the level of estrogen in the female monkey's body. Before T0, and since the monkey's ovaries are removed, the level of estrogen decreases in her body to be approximately none. But after T0, when continuous constant little doses of estrogen are received, the level of estrogen increases in her blood and fluctuates around a moderate value throughout these injections. But when one single overdose injection of estradiol is received, the amount of estradiol suddenly increases to reach a peak. The second curve of document B shows how the LH levels automatically change in the female monkey's blood throughout the experiment. I guess that even in this curve, you can easily distinguish three different variations of the LH level. So it is obvious for you that the change in the level of ovarian hormones, estrogen in this case, exerts a feedback control on the pituitary hormones, right? But now I want you to pause the video for a while and refer to document A of your books to indicate the types of this feedback control exerted on the pituitary throughout this experiment. You must have noticed that in the absence of any estrogen injections before T0, the level of LH increases from around 18 nanogram per milliliter to around 26 nanogram per milliliter. But upon the injection of a continuous constant dose of 60 picogram per milliliter of estrogen, which leads to a slight increase in the estrogen level, the level of LH decreases back to approximately 2 nanogram per milliliter. Since in both cases the variation in the level of LH is opposite to the variation in the level of estrogen, then we say it is the case of negative feedback control. While upon injecting the female monkey with a single overdose of 600 picogram per milliliter of estrogen at time T1, the sudden sharp increase in estrogen leads to a similar increase in the level of LH around 35 picogram per milliliter. Since the variation in the level of LH occurs in the same way as that of estrogen, then we say it is the case of a positive feedback. You can now use what you have learned about the types of feedback control to understand the interaction between the ovarian cycle and the pituitary cycle illustrated in document B of your books. Notice that at the beginning of the follicular phase, when the level of estrogen is very low, both LH and FSH levels increases due to a negative feedback control. Similarly, when the estrogen level moderately increases as the follicle grows bigger, both LH and FSH levels decreases due to a negative feedback control as well. But at the end of the follicular phase, where the follicle has its maximum size, the sudden significant increase in estrogen level exerts a positive feedback on the pituitary secretions that record a peak as well. The peak of LH at this point is called the pre-ovulatory surge, and it induces ovulation. After ovulation, during the luteal phase, the high level of estrogen and progesterone exerts a negative feedback control on the secretion of the gonadotropic hormones. Document C of your book sums up the whole feedback mechanism in one functional scheme. The hypothalamus secretes GnRH to stimulate the pituitary, which in turn will secrete FSH and LH. These pituitary hormones stimulate the development of the ovarian follicles that in turn secrete estrogen. The moderate amounts of estrogen secreted as the follicles grow bigger exerts a negative feedback control on the hypothalamo-pituitary axis that decreases its activity, while the significant amount of estrogen secreted by the mature follicle, known as the Graafian follicle, just before ovulation exerts a positive feedback control on the hypothalamo-pituitary axis to increase its activity and lead to LH surge. Finally, during the luteal phase, the high levels of both estrogen and progesterone exerts a negative feedback control on the hypothalamo-pituitary axis. This mechanism is repeated in the same way in every female cycle. It is very important that you refer to the concept map in page 306 of your books to have an overview on the regulation of the sexual female hormones, starting from the blue part that shows the cyclic modifications in the uterine endometrium. The uterine cycle is governed by the ovarian hormones secreted by the ovarian structures. The growth or formation of those structures are controlled by the pituitary hormones. These pituitary hormones are stimulated by the hypothalamus, which is part of the nervous system. You all know that the nervous system is the system that responds to external stimuli from our environment and controls all other body systems and modify their activities based on the environmental changes. That's why the female cycle is not independent from the external stimuli. The female cycle might be affected by any stressful situation she is exposed to, any medicines she is taking, her food diet, her physical activity, and many other external environmental factors. At the end of this chapter, I hope you enjoyed my videos. Stay safe and take care of yourselves. بأمان الله وبالتوفيق إن شاء الله.